Okay, this is part 2 notes for section 3.3, division of polynomials. So if you want to see how to divide by a monomial, check out video number 1. If you look at the example here at the top, this guy right here, 2x plus 3, is a binomial. So we can't do the same method we did in part 1 video. So no split them up, a little bit tougher. So the reason it says so much fun for me is traditionally, if we were doing this in class, I would have someone explain to me how to do this problem over here on the left, because that's something you learned back in elementary school. But believe it or not, it is very similar. It does apply to the one that's over here on the right, the much tougher looking problem. So I'm going to go ahead through this little step by piece and show you what I mean. So on this guy over here, I think typically most of you would say, well, if I want to divide into a big number and a two-digit number like 32, I got to know how many times is 32 going to 97. And you might have even started off by saying how many times is 32 going to 9, which it doesn't. Now, I was taught a long time ago, and apparently most of you are not, that if you're not sure how many times 32 goes into 97, or you're not sure how many times a big number goes into another big number, just concentrate on the first digit. So I would ask, how many times does 3 go into 9? And I'm sure that you would tell me that it goes in there 3 times. So that's going to help out over here on this other problem. And this is really the easiest way to do it. So that's sort of like the first digit, which is a 2. And this is first digit, which is a 6. So same concept. I'm going to say, how many times does 2 go into 6? And it goes in there 3 times. So we get these two problems started basically the same way. So let me go back over to the one on the left. And what will be the next thing that you do after that you write the 3 up top? Well, you multiply out those two guys, 3 times 32, and you would have a 96. And then you would subtract down. But keep in mind, the goal is to have those first digits, the 9s, match or come really close, because that way the problem kind of proceeds to the right, and you would get to the end and get your remainder and be done with it. So same kind of concept over here on this other problem. I mean, yeah, I want to go 3 times both those guys. So 3 times 2x is 6x, but they wouldn't match. So in other words, when I go to subtract down, I can't subtract a 6x to the third and a 6x. So this 3 that's up here has to have some x's with it. Now, you probably can figure out how many, but I'm going to give you a really easy way of remembering this. If the original problem had x to the third and we're dividing by x to the first, wouldn't it make sense that that guy would have to be down to x to the second to do it? So now check this out. If I multiply 3x to the second times 2x, I get 6x to the third, and they match. Just like over here, the 9s match. Now, here's a spot where there's 2 spots where people screw this problem up at, and here's one. So I'm going to go back over here and point something out to you. When we wrote the 3 up top, did we multiply the 3 times just the 3? Or did we multiply the 3 times the 3 and the 2 to get 96? So we multiplied them both. So here's one thing that might help you out over here with this other problem. I think if you put parentheses around this guy out front, it might remind you it's like doing a distributive property. So I have to do 3x squared times both of those guys. So we've already done 3x squared times 2x. Well, what's 3x squared times 3? And that would be 9x squared. So you have to do them both. So it's similar to the problem over on the left in the fact that you're getting 2 digits, and over here on the right, we're getting 2 terms. Okay, now I'm going to leave the signs off for a moment. I'll show you why in a second. And here comes the second part where people tend to screw up. The problem over here on the left, I think everybody knows, once you get the 96, you would subtract down. And 7 minus 6 is 1, 9 minus 9 is 0. Well, over here, I have to do the same thing. I have to subtract down, but you have to remember, I'm subtracting both things down. So I want to subtract the 6x cubed down, and I want to subtract the 9x squared down as well. So what would happen to the 6x cubes? They would cancel, and that's what we wanted, just like the problem on the left. And what's 7 minus 9? Negative 2. Keep in mind when you're adding and subtracting, the exponents don't change. Okay, back over to the problem on the left. What would be the next thing you would do? Well, we get to bring the 1 down. Okay, now in this case, you would say, hey, 32 doesn't go into 11. And we would write a 0. And you would bring the 7 down. Okay, that's not going to happen over here. But same concept though. So I still bring the next thing down. And then I start over and I see how many times does it go in. So let me go back over to the problem on the left one more time. And I would say, okay, 32 goes into 117 how many times? Well, how many times does 3 go into 11? 3 times. So it's likely to be 3. So see how I'm using the first digit to get an idea? So if I multiply this guy out again, I would get 96, and I got to subtract down. So over here, I want to do the same thing. And I want to say, how many times does 2 go into negative 2? Well, 2 goes into 2 once, obviously. But we want them to match. And if I want them to match, I'm going to have to make that negative. Okay, now if I multiply it out, I would get negative 2x. But I need an x squared. So hopefully it makes sense to you that this guy up top would have to have an x. Now here's another shortcut for you. They're going to go downhill, the exponents. So if the first part of the answer had a 3x squared, well, then this next one's going to be an exponent of 1. It has to be. It's divided. It's going downhill. So I want to do the same thing we just did a minute ago. And I take that negative 1x times both of those guys. So we've already done the negative 2x. But the question would be, what's negative 1x times 3? So I'm getting both of them. And negative 1x times 3 would be negative 3x. Okay, now here's where it gets a little tricky. Over here on the left, if I subtract down, and you can literally use a calculator. There's not a whole lot of thought that's involved there. But what happens if you subtract a negative? It becomes a positive. So nobody screws that one up, but aren't we supposed to subtract both of them down? So what happens if I subtract this guy? He would also become positive. So it's a matter of switching signs. And if you think about it, we've done that before, only in this form. We have one set of parentheses, subtract another set of parentheses. Well, what happens to these signs right here? They switch. So that's the same thing. So I get a 1x and a 3x for a total of 4. So then I just bring the next one down. And you just repeat the process. How many times does 2 go into 4? 2 goes into 4 twice. That's what I put up top. Nice 2. But again, and here's where people mess this up, I multiply out both of those. So 2 times 2x is 4x. But the 2 times the 3 gives me a 6. Okay, and I like leaving those positive signs off because I know I have to subtract that guy down, and I have to subtract that guy down. And I get a remainder of 1. So go back over this problem on the left one more time. There's a 21 left. So we're not doing decimals here. Somewhere along the way, they taught you, hey, you put a decimal after that 9717 and you keep going. So I imagine somewhere way back in your early math careers, they taught you could write like r equals 21, remainder 21. Too wimpy for us. So see if you remember this. The other way of writing it was to take the remainder, 21, and make a fraction out of it. What were you dividing by in the first place? And that's what we're going to do over here on this one. So the remainder was 1. And what was I dividing by in the first place? 2x plus 3. And we're going to stick a plus sign in there because that was positive 1 that we got. So this guy clear up here at the top. Let me go ahead and highlight this for you. The one clear up here at the top. That's your answer. All right, so it's a little crazy, but anything like anything else takes a little practice to do it. All right, we definitely are running low on time here, so I'm going to save these other 2 problems, 4 and 5, for the part 3 video. And if you'd like to learn how to do synthetic division, that's in the part 4 video. Thank you for watching, guys.